Okay, so welcome to the second week. This is the second lecture, and I will explain what will basically happen in the second lab sheet. To recap, the first lab sheet from last week was the installation of the operating system on what will be your working host. So after we go into classes the first week, you'll be allocated the computer, you log into that. We have VMware Player installed onto these computers. And your first lab sheet was the installation of the operating system and creating your first virtual machine, which we call Prometheus. And it will be your host for all of the virtual network that you will create later on. And it will be your DNS server, and you'll turn it into a router as well throughout the semester. So this week, I will explain the virtual network. So the lab sheet for that is on Moodle. If you look on Moodle on today's week, I only have a link to a website because there was no point me having the lab sheet twice. If you go to the week of the 7th of November, which is the virtual network 1, because I do expect you to work on this for 2 weeks, all of the material that you will need is actually there. And this is what I'm using for today's lecture as well to explain everything to you. So the first document is the lab sheet itself. So let's go to that. So the idea behind this lab sheet is that you create a virtual network for your computers inside your virtual machine. So at the end of this lab sheet, you should have one virtual machine that will be called Prometheus, and it will be your host. So it will be the virtual machine inside which everything happens. And at the end of this lab sheet, you should end up with this network diagram. So you should have your Prometheus, and inside that Prometheus virtual machine, you will have 3 more virtual machines in a configuration that we call nested virtualization. So we'll have vPrometheus 0, 1, and 2. So 0, 1, and 2 will actually be inside Prometheus, which will be inside your host. All right, so this is the setup that we are creating. In order to create this setup, we need to configure our host, Prometheus, so that we can basically launch and build the virtual machines inside it. And to do that, of course, we will need VMware to be installed inside that host. VMware in Linux is installed quite easily. So you basically need to go to that link, or you can just Google it on your browser, and it will come up. And once you download it, it will be a file that it needs to be specifically for Red Hat type installations, and it will be a file that ends in .bundle. So to install this, you simply run /vmwareplayer.bundle. The virtual machine, so everything that you do, I'm looking at the questions on the chat, everything that you do happens on the computers in the lab, okay? Because you will need quite a powerful computer to do this, and because you will be working in the labs anyway, so you're not really, there's no setup during which you can work from home for this one. Okay, you can connect remotely from home to the university, and I will show you how if you want to. But all of your work for the logbook and for the class needs to happen on the computers in the lab. So you will be allocated the computer the first week you're there, and you continue working on that computer for the rest of the semester. Okay, so you have your Prometheus virtual machine. First thing you need to do is you need to install VMware Player, download it and install it. You might need to set its permissions using the command chmod 777 to make it actually executable from you. And once you do that, using the / and then the name of the file, you can run this bundle and you can install VMware Player inside Prometheus itself. Once you have a VMware Player installed, you can go about building your first virtual machine. Now, the process to do this is pretty similar to the installation that we created for our host, for our Prometheus host. Okay, the steps are similar. There are differences in the hard drive space, RAM, and so on. So you only need to have one CPU for this, which is the default, so you don't change it. You can give it 10 or 20 gigabytes of space, and you can give it, let's say, 2 gigabytes of RAM. It doesn't really matter. I think 2 gigabytes should be the maximum for it. And choose nothing for the network adapter. So basically, it is the default, so leave it as it is. for the network configuration. We will change this later. However, this is the easiest way to give full internet access to the virtual machine as soon as it's built, as soon as it's installed. You finish, download, let the system do the installation, follow all the steps, accept all default configurations and everything. The only really important change in this is that you need to remember to create a GNOME desktop type of installation. So you need to go into software selection and make sure that you choose GNOME desktop for it. Once you do that, you can name it as well. So name it vPrometheus 0, and then you're done. Again, I will want you, just like the Prometheus host that you created, I will want you to always log in as user root in this, because we are in a lab environment and you will need the permissions for it anyway. So create a user account, but you should never use it. You should always log in as root. So once you do that, and once that process is finished, you will have your Prometheus host, and you will have installed VMware Player inside it, and you will have created your first virtual machine out of the network, which in the diagram is the one up here. So you have created vPrometheus 0. You do need to create 2 more virtual machines, and it's quite easy and straightforward to do this. You don't have to repeat the process of building the virtual machine again. You can actually clone the virtual machine that you've already built. So to do this, you physically need to go into the directory /root/VMware on Prometheus, and then look for the folder vPrometheus 0, copy it and paste it twice in the file manager, and rename it to 1 and 2. Follow the process, start a new virtual machine, go into your VMware player, click open. It will ask you if you copied it or moved it. You need to say I copied it, so that it creates a new VMware ID. So a new ID for the virtual machine itself, so that it gives a different MAC address and hard drive information for the new virtual machine that you created. And once you do that, then you have basically your cloned network. So you have 3 virtual machines that you can use that are called vPrometheus 0, 1, and 2. All 3 of them at the moment should be in NAT network configuration, and they will automatically get IP addresses and work from the host itself. Now, this is something that we need to change, because we need to have a particular network infrastructure, and this is where things will get slightly more complicated for this. So there are various modes that VMware supports for networking, and it has network cards that are called VMnet something, VMnet 0, 1, and so on. By default, it supports network address translation, and this is what we left it at. However, we want to be using something else. There are generally three different modes that VMware supports. So there is nothing, which is network installation. There is bridge mode, which basically assumes that the network card inside the virtual machine is on the same subnet, on the same network as the network card on the host itself, which is exactly what we have for Prometheus, actually, to the outside world. And then there is host only, which allows us to give a public IP address or any IP address we want really on it, and it does not have networking configuration. What we will create is we will create a custom host only network configuration, and we'll do that by running a script and altering actually the network capabilities of VMware Player itself. So we have that script, and I will explain how it all works and everything. You don't really need to do much about it. But what we need to understand is the network infrastructure as it exists on VMware. So we need to have customized VMnet virtual network cards. So if we look at our network diagram, the host itself will have a VMnet 0 and a VMnet 1. So these are the two virtual network cards on Prometheus itself that will connect to the corresponding virtual machines. So virtual machine 0 will also have a VMnet 0 network card, and they will connect to each other. You could look at it as if VMnet 0 also acts as a switch, although it's not really. It's simply a connecting point, a piece of software, a script that's running on the operating system, and allows the two network cards between vPrometheus 0 and the host to connect to each other and communicate with each other. The same happens for VMnet 1, and of course the same happens for VMnet 2 that connects virtual machines 1 and 2 together. So we need to create the infrastructure for those VMnets 0, 1, and 2 to exist in the system, and we need to make them exist in such a way that we can manipulate them, given the IP addresses that we want, start them up in our own time, and so on. So this is customization that is offered beyond the native capabilities of VMware itself. So we'll do this by running a couple of scripts. The first script that we'll use in order to do this is a script called VM_subnet. So this VM_subnet script is this one. So I will zoom in on this. Don't worry, the script exists and you can see it on Moodle. You can download it at any time, and I will explain pretty much everything of what it does. So essentially, it's a bash script, and we've been working on it for years, basically changing it every year. There are comments explaining roughly what it does. You can scroll through it, have a read, and see what it does. It basically starts up drivers, starts up devices, kills previous devices on the system, and so on. The most important bits, the ones that we really care about, are the bits that configure the network cards VMnet 0, VMnet 1, and VMnet 2, and VMnet 3 we will not actually need. So we just need VMnet 2, 1, and 0. So these paragraphs, these parts of the script will basically start up the device drivers and start up the interface. So as the comment here says, start process that associates the device driver with the network card, and then bring up the interface. When we bring up the interface, we need to give it a specific IP address. So this part is where we give all of the information, all the networking information that we need for our network cards. Now in the lab, we have 48 computers, and we have 48 Prometheus virtual machines, and inside each of those, we will have 3 virtual machines each as well. So we need to have a system, we need to find a way so that you all have public IP addresses and you don't all use the same or similar IP addresses. In order to do this, we've done something that's called subnetting. So we're taking 3 different subnets and we are subnetting on them. So it's subnets 30, 31, and 32. So if we look at our network diagram, this network diagram is an example that's made for my own personal computer. Okay, so as you can see here, VMnet 0 on Prometheus and vPrometheus 0 belong to subnet 30. Okay, so they have an address of 148.197, which is the class B network that belongs to the university. Everything in the university starts with that address. And we're working on subnet 30 on this branch. The branch on the bottom of VMnet 1 on Prometheus and VMnet 1 on vPrometheus 1 exists on subnet 31. So this is 31, same as this one. And then finally, we have a third network, a third subnet, which is 32, and it exists between the VMnet 2 network card of vPrometheus 1 and the VMnet 2 network card of vPrometheus 2. So essentially in here, we have 3 different networks. And if we add the 4th network, which is subnet 28 that connects Prometheus to the outside world via the bridge, then we have 4 networks that we need to deal with eventually so that we give full internet access to all of the computers in our little virtual network that we've created. So to do this, we need to allocate IP addresses to each of the computers in the lab. In order for this to happen, there's another file that's called a2.net subnets, and that is available on Moodle as well. So what we have here is we have the network diagram of a2.net. So I sit on this desk, 10 and 11 are mine, there's the other desk for other lecturers on the other side, and these are all of the computers in the lab with their corresponding IP addresses. So if it's 97, then it's 148, 197, 28, 97, 28, 98, and so on and so forth. So these are the public IP addresses that exist on the outside world for the actual physical host that you're sitting on. Then you will have your Prometheus virtual machine. That will be that plus 100. So if you're sitting on Farina and your host is 97, then your virtual machine will be 197. If you're sitting on Hawthorne at 65, your Prometheus will be 165. So depending on which computer you're sitting on, we will have a list of the computers and the little ranges of addresses that those computers can use. So if you are sitting on Farina and you're on 148.1.7.28.97, you are the first computer in the lab, and you can use the range available for the first computer in the lab, which is from 30.0 to 30.3. As this explains, the first address will always be your network address, the last address will always be your broadcast address, and your usable IP addresses for your host itself will be 30.1 and 30.2. So you can use those IP addresses on your network cards. You can never use the network or broadcast address for your network card IP addresses. Yes, these are simply there to tell us what the beginning and what the end of your network range actually is. So if we scroll all the way down past the list with all of the computers in the lab, there are some reserved IP addresses, and then there is my computer all the way in the end. So my network address is 252, my broadcast address is 255, so my usable IP addresses are 253 and 254. So if I wanted to configure this script, then I would have to use an IP address of 30.253 here. Okay, because this would be the IP address that I would have to have here. So this, for my computer, would have to be 30.253, because this is the range of addresses that belongs to me. This is my first usable IP address. Since my first usable IP address is 30.253, my second is 254. So if I go back into my network diagram, this should for me be 30.254. If we then move on to the other network cards, we are now on another network on subnet 31. So I can again use the address of 253, but this time for subnet 31 instead. So I would have 31.253, 31.254. And then of course, in exactly the same way, I would have 32.253, 32.254 here. So this is how I populate all of the IP addresses for all of my network cards that I have on my virtual network, and that's what they need to be in the end. Now, these network cards in the virtual machines themselves that we've created, in order for them to get an IP address, they will need to be configured on the network card settings of the virtual machine itself. These two IP addresses are the exception because these will be created by us running our custom script. So our script is VM subnet, so it's the one that starts up the network card, so we need to configure it. So I will need to give it an IP address of 30.253, and then I will need to give it a netmask, network address, and broadcast address. The network address for me on my computer, according to my file, is 252, and my broadcast address is 255. So now my script should be 30.253, then the network address should be 30.252, and the broadcast address should be 30.255. What we then need is the netmask. The netmask on a default class C network should be 255.255.255.0. On my example, in the way that we've split the lab, should actually be subnet mask 255.255.255.252. The reason for this is because we've subnetted an entire class C network. So we've taken networks 30, 31, and 32 that would originally start at 30.0 and end in 30.255, and we've split them into all of the slices that will split the computers. We basically split them into 64 slices. We've done this because we have 48 computers in the lab that we need to accommodate. So we need to have IP addresses for the 48 computers in the lab. the difference or the problem or the limitation really is that if you do subnet a network, you need to do it in a power of 2. So a network that's subnetted needs to be 64 slices or 32 slices or 16 slices or 8 slices or 128 slices and so on. So we went with the slice that allocates all of the IP addresses that we have that we require, so 48 computers, and eventually, yes, of course, we're left with a few spare ones that we don't actually use in the lab, and we have reserved them for use in our servers and so on. The fact that we split the network into 64 slices, it means that now we've changed the subnet mask. So computers don't actually do decimal, they do binary. Yes, so when they do binary, they look at ones and zeros. So a subnet mask of 255, 255, 255, 252 translates into 8 ones, then another 8 ones, then another 8 ones, and then 1, 2, 3, 4, 5, 6 more aces, 6 more ones in there. So now we've moved the subnet mask, and instead of it being 8 ones, 8 ones, 8 ones, and 8 zeros, which is for the default class C subnet mask, is now changed into this. This and this are the same thing converted from binary to decimal and so on. Yes, the conversion works in that all of the bits here that are ones are activated, so they count. So this is 128 plus 64 plus 32 plus 16 plus 8 plus 4. So that gives us 252 if you add them up. This is because we only use 2 digits for what we now call the host part. And what do those 2 digits mean here? Everything is on Moodle already. Yeah. So those 2 digits mean that we can have 4 different combinations, 4 different numbers out of those 2 digits. So we can have 0, 0, we can have 0, 1, we can have 1, 0, and we can have 1, 1. So we can have 4 possible combinations out of this. Again, all of this because of the way that we've split the subnet into 64 slices. Yes, out of those 4 combinations, we have 1, which is the IP address for our network, 1, which is the IP address for our broadcast, and 2, which is for our usable IP addresses. So the new little networks that we've created actually have 2 usable host IP addresses, 2 IP addresses that we can use for our network, which in my case would be 32.53.254, which I've allocated to my computer network. The /30 here means that this is a 30-bit long subnet mask, because 8 plus 8 plus 8 plus 6 gives us 30 bits. So default class C, for example, would be /24. So this is what these all actually mean. Now, this is a very quick crash course into this thing. Okay, so what I do want you to do once, before you come into the lab for this actual section, for this actual lab session, is I want you to go onto this website. There are literally hundreds of websites for you to go and do some research on networking, CIDR, subnetting, and everything else. I have always preferred this particular website. Okay, so I discovered it quite a few years ago, and they have quite good content on them. So on this particular link, they talk about subnetting. So they talk about basic subnetting concepts, everything else. They have useful graphics and everything, so you can understand it. So if we click on this, for example, they take IP addresses, they explain the classes, and then they do pretty much what I showed you, but with nice colors and everything, and explain how everything actually works in this. Yeah. There is a bit of a warning in the beginning of this, that if you haven't looked at IP addresses before, so if you don't know what class A, class B, and class C is, then it's a good idea to actually go into networking and then go into protocols and look at the IP protocol as well. For me, in your free time, and generally, if you want to have a more in-depth knowledge about all this, you should really go into this website and read everything that has to do with networking. You will need routing. You will need routing as well later on and everything. You can learn about network address translation, what VLANs are, and so on. At the very least, I would like you to please have a look at IP protocols and subnetting. All right. So now that we have an idea of what our IP addresses should be for this, and we have our script ready, our VM subnet script. So we can go here. So we input all of our IP addresses here and here. This VMnet2 doesn't need to have IP addresses because this will not start up as an interface on the host. So it will not exist on this one. It will only exist as a process so that this and this host can connect onto them and basically communicate with each other. So we don't need to give it an IP address. We just need to start it up as a process that associates the device driver with the network card. And VMnet3, we don't actually need at all. So you can actually just select all, delete this, and get it out of the way. Once this script is complete, you then need to go back onto Prometheus, where it resides, and you need to make sure that you change its permissions and you run it with /VM subnet. If you run the script and you type ifconfig, which is a command that gives you, distracted by the chat, cut. So as I said in the beginning of this, everything for this particular lecture are located into the week lab that will do this. So they're on the 7th of November. Okay, so all of these files are on the 7th of November because there was no point for me putting the same files twice because I am explaining the lab sheet. Okay, so we are here and I am talking about what we will do in the second and third week in the lab eventually. Okay, so if you expand this, everything is in there. So now that we have our script and it's configured correctly and we run it, if we type ifconfig, which is the networking command to show us exactly what network cards we have in the system, you should be able to see VMnet0 and VMnet1 running as network cards on the system and having an IP address. You can also look at the processes that are running in the system and you can filter them by the word VMnet, and you should see processes VMnet0, VMnet1, and VMnet2 running on your system. If you do not, you need to call me to your desk because something has gone wrong. Now, once we have the VMnet network cards on the host itself, on Prometheus itself, we also need to configure the virtual machines that we built to be able to have those network cards. Because remember, as I said before, VMware by default only supports nothing, host only, and bridging. So we need to do something to the virtual machines so that they support our version of host only, which we will call custom. And once we have the custom option, we can actually choose which network card by name we want each of the virtual machines to connect to. So VMnet0 will be the network card that vPrometheus0 will use. vPrometheus1 will have two network cards, and they will be VMnet1 and 2. And virtual machine 2 will have one network card that will be VMnet2. In order to do this, we need another script that's called fix vmnet-dev. This is also located in Moodle. And you can use this script simply by downloading it, changing its permissions if necessary, and running it. You don't actually need to make any changes inside this particular script. So once you download it, you need to save it into each of the folders of the virtual machines. So back when we were cloning the virtual machines, we created 3 folders inside the /root/VMware directory. One was the vPrometheus0 folder that was created automatically, and the other 2 were vPrometheus1 and 2 that we simply copied from 0. So all you need to do is you need to download this fix vmnet-dev script, save it inside each of these folders, and run it with /. So /fix vmnet-dev in a terminal will basically edit the configuration files of those virtual machines, and in the networking sections, it will actually give them 3 network cards each that are custom, and you can do whatever you want with them. Special consideration for this part, the virtual machines 0, 1, and 2 must actually be powered off, not running and not even suspended. So they must be properly powered off via the operating system, so that when the hardware devices change, when you run the script and you change the hardware of the virtual machine, the operating system sees it again, and on startup, it will see the 3 network cards. So once you run it, your virtual machine settings will have 3 network cards. And then what you need to do is you need to go to the virtual machine settings of each of them and change the network card configuration to reflect what you wanted here. So in virtual machine 0, you will delete the second and third network cards, and you will set the first network card to connect to VMnet 0. On virtual machine 1, you will delete only the third network card and set the other remaining 2 network cards to 1 and 2. And in the third one, just like in the first one, you'll delete the second and third network cards and set the remaining 1 network card to connect to VMnet 2. Once you do this, then you have essentially reached the end of the lab sheet. So you should have 3 virtual machines inside your Prometheus virtual machine, inside your host, and they should be able to ping their neighbors only. So from 0, you should be able to ping Prometheus. From 1, you should be able to ping Prometheus, and you should also be able to ping vPrometheus 2. And from vPrometheus 2, you should only be able to ping vPrometheus 1. Now, once you have the network cards in the virtual machines, in order for the pinging to work, your virtual machines themselves need to be configured correctly with the correct IP addresses, default gateways, and everything else. To do that, you simply power on the virtual machines, go into the network card settings, and change the IP addresses to whatever they need to be in there for each of the network cards. So the subnet masks in here, for example, will always be 255, 255, 255, 252 for all of them. The IP addresses will be whatever you have on your network diagram. And the only one that is, the only thing that's relatively tricky, it's not if you know the rule, is the default gateway. The rule for the default gateway is that the default gateway for any network card is the IP address of the network card that you see next on your way towards the internet. So for the IP address here, so if I was working on 250, my gateway would be 249. So on this computer, if I set the IP address at 250, then my gateway should be 30.249. On this network card, when I configure it, my gateway should be this network card. For this network card, it should be this one. And for this one, it should be this one. So always the next IP address you see on your way towards the internet. And this is how the default gateway on them works. If you have this correct, then you should be able to ping neighboring virtual machines only. You will not have internet access because you are trying to go to the outside world across multiple different networks. And to go across multiple different networks in IP protocols on the internet, you need to have routing in place, which will be our next lab set. So we will set up routing on your Prometheus and on your vPrometheus 1 host so that you can have internet access, full internet access everywhere. Okay. So this is what the second lab set is. I know there are quite a few moving parts into it. There are scripts and configuration files and configuration changes that you need to make. Remember, you will have 2 weeks to work on this, so it's not only 1 week. And you can come in the you can come in the lab and put some extra time into this as well once we've started. And of course, you can ask anything you want about it as well. The important thing is that you start with a network diagram. So what I want you to do before you actually come into the class is I would like you to know which IP addresses you're supposed to be using. And for this purpose, I have a virtual network diagram template. So on Moodle in that week, there is a Word document. Oh, I actually had it already. Okay. So there's a Word document that is easy to edit. Okay. So if I'm working on this, let me zoom in a little bit. So if I'm working on my network with our current network configurations, so what I will need to have is, as I said, my address for this guy should be 253, and my address for this guy should be 254, and rinse and repeat for the entire network. Come on. Okay, so now I have the network diagram that corresponds to my computer. So even if you don't really understand in full depth all the subnetting and networking that happens behind it, the easiest thing that you can actually do is go into the subnets file, find your computer, and put those IP addresses in there. So if you're on Rossi, you need 65 and 66. If you're on Perez, you need 89 and 9. And that's it. Okay. So, question by Kat, what was the first in class session? So the first in class session will be on the 5th week. So I think it's 2 weeks, 3 weeks from now. Okay, and you can start working in the lab then. So from then, once I allocate all of the computers to you, you can actually come and work in the computer. How do we know which computer is ours? Well, it will be the computer that you will sit on the first day. So on that Tuesday on the 5th week. And I actually have this printed for every class, and I write down your student numbers on each of my lists. So whichever computer you sit on, you will always go back and sit on that computer as well. The other detail to that is, in order to log into those computers, you don't log in with your normal username, you don't log in with your UP, whatever. You log in with usernames VM1, VM2, VM3, and so on. So if you are No, so this is an Anglesey building, A2.net, second floor, the network level. Okay, so you'll all have your own user accounts on the computers that you're logging in. I will ask you to change the passwords, of course, the first time that you're in there. And so that computer will be yours because only you will be able to log in as, for example, user VM3 on Android. Yes, Adam, exactly, yes. So the subnets file itself is used as an example, essentially, yes? So this example is made for subnet 30. However, subnets 31 and 32 would be exactly similar to this. The only thing that will change will be the third part of the IP address. Okay, so this is the network configuration that we will be creating. So we'll have our own little virtual network, our little IP addresses. We'll run a couple of scripts to create the network cards and customize them in the way that we want to customize them. And then once that's done, you should have a network that is ready for you to try other technologies onto it as well. And after that, we'll do some routing and some DNS. Okay, so I will stop the recording.